Alright guys, this is example 3 in the area of solving questions that involve calculation of chronometer rate and error as well. So I'll put that here as well. So I'll provide you with the links to examples 1 and 2 in this area with this video. But this is the third type or third example in which a question may be formulated when it comes to solving chronometer rate and chronometer error. Alright, so let's take an example that it's 29th of November 2019, which of course hasn't arrived yet, but that's alright. And it's morning on 29th of November, and the estimated position of the DR position, DR also stands for dead reckoning. So the dead reckoning position, which is an estimated position of the ship, is 2627 north and 130.27 west. The chronometer at point showed 5 hours 46 minutes and 20 seconds. So for those of you who don't know what a chronometer is, a chronometer is a device. It's like a clock which is kept on the ship's bridge that provides the GMT time. Now often the chronometer runs ahead or lags behind the GMT, and that is called the chronometer error. So we have to determine the chronometer error and correct the chronometer so that it reflects the correct GMT time always. Now this difference is normally in few seconds, but for academic purposes, like you will see in some questions, the error is shown as a large error, so for calculations it becomes easier. Anyhow, so we'll continue with the question. So if at 600 hours GMT on 14th of October 2019, that's going back a few days, the chronometer was 0 minutes 10 seconds fast. So this is the error. This is the chronometer error. So on 14th of October, the error was 0 minutes 10 seconds fast, but its daily rate was 4 seconds losing. Find the GMT. So that means that the error was fast. That means chronometer was running ahead of the GMT, but it was losing 4 seconds. So 4 seconds losing means the error of fastness was getting reduced. So from 10 it became 6, from 6 it became 2 seconds fast at that rate. Alright, so that's what it means. So from 0 minutes 10 seconds fast, if I say 4 seconds was lost, so in one day the error then becomes 0 minutes 10 minus 4 6 seconds fast, and then the next day it will be 6 minus 4 2 seconds fast. Alright, so that's what it means by 4 seconds losing. So we'll go into the solution. So to figure out the solution, we have to first find out which is the correct GMT time, because when the chronometer shows the time on its clock, it's basically like an analog watch. It's not a digital clock, it's an analog clock with two hands, right? So when it says 5:46:20, it could be 5:46:20 in the morning or 5 to 46:20 in the evening. The chronometer time gives you the GMT time. So we don't know what is the time of the GMT. The time on your ship and the time on the GMT will be of course different depending on your longitude, as I will show you in the example here. So whenever the chronometer time is given to you, just add 12 hours. Alright, and then write down the other scenario which is possible. So there are two scenarios of chronometer time. Then the error is not determined, of course, so we'll not yet determined. Yes, the error we know is on the 14th of October, but we have to calculate for the 29th of October, or rather 29th of November, sorry. Alright, so then GMT will say approximately was again 5:46:20 or 17:46:20. So if you apply a correction of LIT, which is longitude in time, to the GMT time, you will get the local mean time. That local mean time can also be called the ship's mean time or SMT. It cannot be called that because the local mean time or LMT is a correction of the LIT, but ship's mean time refers to the zone correction. So we don't go into all that. So let's assume local mean time, let's assume that's the time on the ship. Alright, so that's the time on the ship based on your longitude. So I will not say it will be called SMT. We don't go into these concepts, but if you want to go into these concepts, please watch my other videos. Alright, so anyhow, so we apply this longitude, and why we are subtracting is because we are in west longitude. The ship is in west longitude. When the ship is in west longitude, that means the time at GMT is more than the time on your ship. You are running behind GMT. Alright, if you are in east longitude, the time on your ship will be more than the time at GMT. GMT will be behind you. So the LIT or the longitude in time correction you get by dividing the longitude by 15. In this case, of course, the DR long given to you was 130.27. You divide by 15, you will get 08 hours 41 minutes and 48 seconds. So apply this longitude in time correction. Since it's west, GMT will be the best, so you will subtract it. So if you are wondering how I subtracted 8 hours from 5 hours, just add 24 hours here and make it a bigger number, and then you can subtract it. So in this case it is 21:04:32 local mean time on my ship, and then in this case it's 9 hours 4 minutes 32 seconds. Again, that's another scenario of local mean time. So how do I know which is the correct time on my ship? Well, the question itself says that it's 29th of November and it's morning. So out of the 2 LMT, I know that the morning time is 9 hours. So what I'll do is write 29th here. So this is 29th of November. So therefore the time at GMT, because I've gone back 8 hours from 1700 hours, although GMT is ahead of me, the date is still the same. So at GMT it's 17 hours 46 minutes. It's still 29th November, and on my ship it's 9 hours 4 minutes 32 seconds, but it's 29th of November, and that's the local time. So therefore this GMT time, I will use this approximately GMT time. Why I say approximately is because no error was applied yet, right? So the approximate GMT time is 29th of November, 17 hours 46 minutes 20 seconds. So first we determine this, and then we can apply the error that we'll calculate. All right, so what you have to find is basically the GMT, right? So to do that, you have to find the chronometer error on the 29th of November. You know the chronometer error on 14th of October, but you have to calculate for 29th of November. All right, so let's get into it. So GMT 14th of October at 600 hours, as you know the error then. So this is known, but we have to find for 29th of November 17 hours 46 minutes and 20 seconds, because that's the approximate time. So this is where I got this time from. Alright, so let's calculate how many days and hours it is. So if you calculate the interval between 14th of October to 29th of November from 600 hours to 1746, you will get 46 days and 11 hours 46 minutes 20 seconds. Now if you divide 11 hours 46 minutes and 20 seconds by 24 hours, you will get 0.5 of a day, because it's almost 12 hours. 12 hours means half of a day. You add 0.5 to this 46 days, the total interval is 46.5 days. So if you're wondering how I got this 46 days and 11 hours from, you can see this calculation here. So we'll start from 14th of October 6 o'clock to 14th of November 6 o'clock. That it's easier for us to calculate. So that's 6 to 6, so we can calculate the days quicker. That's about 31 days. You can calculate it yourself as well. So from 14th of November 6 o'clock to 29th of November 6 o'clock is another 15 days. But we need for 29th of November 1746. So that's why for 29th of November 6 o'clock to 29th of November 17 hours 46 minutes gives you another 11 hours 46 minutes 20 seconds. That's about half a day. And that's why the difference between 14th October 600 hours to 29th November 1746 is 46 days 11 hours 46 minutes 20 seconds, or as I shown above, it's 46.5 days. Now the question says that the daily rate was 4 seconds losing. That means the chronometer was losing 4 seconds. So I've told you before, 4 seconds losing, that means basically from 0 minutes 10 seconds fast, if I lose 4 seconds, it becomes 0 minutes 6 seconds fast. Alright, although it is still fast, it is reducing the rate of the fastness. Alright, I know it's a bit complicated, but I hope you understood it. So although it's 0 minutes 10 seconds fast, because I'm losing 4 seconds, the rate of fastness is being lost. So if I'm losing 4 seconds per day in 46 point, accumulated rate in 46.5 days is 4 by 46.5. So 4 seconds multiplied by 46.5 days, which is about 186 seconds, and that is slow. Why? Because I'm losing, so the clock is going to become slower, right? If I lose time, right now the chronometer is fast, alright, but I'm losing 4 seconds every day, so that means the chronometer is going to now become slower. 186 seconds is also equal to 3 minutes and 0 seconds divided by 60. So 1 minute is 60 seconds, so 186 seconds will be 3 minutes and 06 seconds, and then again it is slow. So if the chronometer error was 0 minutes 10 seconds fast on 14th of October, this is 14th of October, alright, that means the chronometer at that point of time was fast. That means it was running ahead of the GMT. So if the GMT was say 12 o'clock, the chronometer was showing 12 o'clock 0 minutes and 10 seconds. It was running faster. But what has happened is that over a period of time, that is from 14th of October to 29th of November, you have actually lost 4 seconds a day, which equals to 3 minutes 6 seconds a day. That's right, 3 minutes 6 seconds over a period of 46.5 days, right? So accumulated rate for 46.5 days. Alright, so this becomes 3 minutes 6 seconds slow. So that's why you will subtract it, because like I told you that you are losing 4 seconds a day. So if on 14th of October, if I can make you understand, it was 0 minutes 10 seconds fast. This is fast, right? 15th of October, after 24 hours, it will be 0 minutes minus 4 seconds, so 6 seconds fast, right? I'm losing 4 seconds a day, 4 seconds lost. So although the error is still fast, you are losing 4 seconds. So the rate of fastness is getting reduced. So on 16th of October, it would have been 00 minutes, again 2 seconds, but fast, because again you lost 4 seconds. But on 16th of October, if you lose 4 seconds to 17th of October, now you are no longer fast. You will become 00 minutes 02 seconds slow, because now you have gone on to the other side. So fastness after 2 seconds, now it has gone to the other side, it becomes 2 seconds slow. Get my point? So that's the principle. So now if I have to calculate this day by day, it becomes time consuming, and that's why we can calculate as an accumulated error, right? And that's why if I come above again, I'll change the pen so that you know it. So for 3 minutes 6 seconds was what we lost over a period of 46.5 days, and that's why after 46.5 days your error is no longer fast, it has now become 2 minutes and 56 seconds slow. Alright, that's what I was trying to show you through individual calculations. So this is, if this is your error on 29th of November, if your chronometer time on 29th of November is 17:46:20 and the error was slow, that means your chronometer is now running behind GMT. So your GMT time, your error should be added, and your GMT time and your chronometer needs to catch up. So that's why it means your chronometer is now 29th of November 17:49:56, because you will add the error when it is slow. If it was fast, you would have subtracted the error, but because it is slow, you will add the error. That means chronometer is running behind GMT. Alright, so this is the third example in this series. I will provide you with the links of the other 2 examples as well. Just watch all the 3 videos, and if you have any questions, please write to me in the comments. Sometimes students get confused after hearing about rate of fastness was losing or rate of slowness was gaining. If you really think about it, it's quite simple. So if I say rate of fastness is losing, that means the chronometer error was initially fast, but the rate of fastness was losing, it was reducing, as it was in this case. Alright, so from 10 seconds fast, every day if you lose 4 seconds, it becomes 6 seconds fast, then 2 seconds fast. So that's how it was losing. So anyhow, I'll try to put up more examples in the future, but you've got these 3 examples now. Watch these 3 examples, and if you have any questions, please write to me in the comments. And thank you again to all the lovely subscribers and people who watch my video and give me comments and encourage me with your feedback. I really appreciate it. I'll see you soon with my next video. Hope these videos are being helpful to you.